Yay. Finally one that's not a complete effing nightmare. Okay. Y'all, the last couple of these I've done have been a nightmare. And by the time I got to the end of the movie, or the end of the video, I'm just kind of like, I want to be done. Sorry about that. My attitude has been here lately. I've had a lot of stress on me. I've had a lot going on. A lot of shit going down. A lot of stuff. Okay. So I got notes. Now y'all know my affinity for liking to read notes out loud on video. As you all know, when I was in the 3rd grade or the 4th grade, they had me read something out loud, and I struggled so hard everybody had to laugh at me. Well, guess what? I don't effing care anymore. Okay, talking about this guy here. He says it's a 350 because it's a 350 HDV. All right. I received this amp as payment for repairing and tuning a friend's antenna and coax. The story I was given was an Astron power supply went bad and wiped out the transistors. I replaced the Toshibas with a matched pair of RF parts, comma, amp came back to life. I would like you to do the same treatment to this. This is RO number 16, by the way. Full treatment. Definitely want the bias checked on both amps and adjusted perfectly, which is this resist horror. That one right there. I got some mil standard measured resistors. We'll check this one and that one there. Make sure they're perfect. Okay. Power supply went bad, supposedly wiped out both the pills. This has got 2879 Toshiba non-red dots in it. Which, yeah, if it had AC or high voltage on it, it's gonna dead. These are in great shape. The tins are in relatively good shape. The 667 is gonna need a little bit of work. It's got like house paint stuck on it or something, but it happens to be in the hands. With the dude with a soldering iron tattooed on his arm. Okay, he knows what he's doing. Let's talk about the 667. Inherited from a deceased family member, not much known about its life. I would like you to do your McNasty to it. I want all the upgrades possible. I'm going to stop there in his notes. What he's talking about is he wants preamp, power wires, all that kind of, the mashigity done to it, which is all simple stuff. We're going to rip this shitty coax out of here. We're going to replace it with like 316. Or if I wanted to get real McNasty with it, we put RG400 on it. Way overkill. Either way, he wants all the McNasties. It includes removing this combiner in the back and going to a bigger one. And there's another couple little things we could do that make it just a wee on the outside better. Okay. Power wires, LED lamps, preamp upgrade. I know this TS amps can be hard to tune flat. Say what? Okay, hold on. Let's run through that one sentence one more time. I know that TS amps can be hard to tune flat, but as absolutely flat as you can. If changing transformers and such will increase output, I would like I'd like to discuss that with you as well. Budget is not an issue, obviously within reason. Okay. The boards and the transformers limit the operation of the amp. The problem with this is the way the switches are wired. 100% of the incoming RF and outgoing RF goes through these switches, and there's a whole lot of moving the mashig around. The RF mashigity, we're moving it around all at 100 ohms, and then jumping it back to 50. It's a little bit of a trick. The best I've ever gotten out of a 667 was somewhere in the area of 850 watts. And I honestly have no clue what kind of magic pixel dust got dropped upon that amp that allowed it to do that. There's a lot of loss and there's a lot of design inefficiencies that are here in this thing. What this has in it, that makes it a little bit unique, because usually when they show up here, these have been ripped out and thrown in the trash. This is the no keyboard. This is the amp, or the board, that allows this thing to transmit up to, oh, what is it, 23 megahertz? And then it's like a brick wall, you know, standing there going, thou shall not pass. It will not let this key up on the 10 meter band. They did this to help with a legal issue they were having with the FCC at the time. Somebody's already bypassed this, but they left it in here. It's coming out. I've got to call Mr. K. I'm probably going to do it tomorrow, because I need to know how much he wants to set this up to have as drive and how much he wants to set this up for drive. So if he's got like a 25 watt radio, this is his thing right here. If he says to me anything silly like, oh, I want a striker, I'm gonna be like, dude, no, just no. Put the candy canes away and step away from the Christmas tree and all the white powder. I'm not gonna mention that Christmas was like 3 months ago. Okay. These are a low drive amp. They were built for a different era. Today, everybody runs around and they've got, you know, a 100 watt radio. The face of this thing is in really good shape. It's got dust on it. I know how to clean dust off. We'll be fine. In my opinion, the LED bulbs that we are able to buy today do not work as well as the incandescent bulbs that were in here stock. So let's, yeah, it's got incandescents. We're going to leave the incandescent bulbs in there, and not switch out to these here. Where did I put you? You're over here. Here we go. Oh, airmail. Okay. These LEDs, they look right. They look right. But they're not a perfect fit. And they're this ugly frickin' flat bright white and not the soft ambient glow that we're used to. So if the light bulbs work, I have a tendency to leave them. Light bulbs in here last for decades, I've found. The LEDs, on the other hand, I will spend 3 hours replacing these 4 switches because I got to tweak them just a little bit. I got to add a little bit of solder to each one of the legs and kind of tweak them around to make sure they make good contact on the inside of the switch. Otherwise, I can stick them in there and they'll work here on a bench, and then the first time the amp goes, oh, all of a sudden half of them won't work because they jiggle away loose. It's like throwing a hot dog down a hallway, you know, or waving your dang around inside the hall and tunnel. Just no one's going to know it's there. The light bulb's sitting in the hole, but it's not making contact to the tabs on the inside of the switches. So this is easy. This is relatively easy too. Now, he does not say that I have an unlimited budget within reason here. Honestly, what I want to do is when I grab my alligator clips, I want to set it up on the bench and I just want to soft key it. And I want to see what works and what doesn't work. Be kind of cool to see, like if the power switch was on when the power supply went down. We've got a couple other things that we've got to go look at other than just the bias and the transistors, that kind of thing. Like the key-in transistor is going to be wiped out. It couldn't have been that hard of a hit because these 2 caps are still intact, but we are missing the L power wire. Missing. So we'll see. Let's start here and then we're going to come here. Okay, so no heat in the amp. Power wire, oh, key-in transistor worked. Okay, I got 12 volt power fed to case ground and the positive distribution bus on the far right hand corner. preamp works. The delay light is bad. All right. Let's turn the amp off. What we've got going on over here is a 50-watt slug and peak. So, 2 and 2 and 2. So 20 whole watts. We're going to short quick key this, and where I'm going to be looking at is over here on the oscilloscope. We're going to be looking at that green line. Okay, and I'm measuring our bias voltage. So let's go ahead. We can obviously talk through it. Hello, 1, 2. Our pass-through tune is phenomenal, by the way, for a Texas Star. Hello, 1, 2. It's pretty good. Pretty good. All right. So let's start over again one more time. I received this amp as payment for repair and tuning a friend's antenna and coax. The story I was given was an Astron power supply went bad and wiped out the transistors. Let's watch this one more time. So we're going to put, let's turn our 5-watt to forward. Put 1 watt in it. Okay. Let's turn our mic gain off so we don't blast everything that I got probed here completely out of the water. We got 50 watts out and it's trying to climb. 1 watt going in. Both the transistors are heating up. So bias resistor is good. Our lamp's working the way it should. My friend, let's see, what do we got for reference? So let's see here, position. Okay. So this cursor is our yellow indicator, which is the RF coming through the bench. The green is the probe, and the blue is my auxiliary. Aha. One box worth of growth. I have this currently set at 0.5 volt. About 586 millivolts. All right, we're done looking at that. My man, I don't think there's anything wrong with this box other than the light bulbs burn out in the front. And it needs power wires put in it. So we're gonna go ahead and we'll do the power wire upgrades to it, and we're gonna replace the preamp with the nice tight bright one that allows us to have 25 dBs less noise rectification going on, which means less static, by the way. Perceived less static in the receive. I should do a whole video on preamp noise floor and circuitry sometime. Not today. Not in this minute. So, good news is I don't think you need any transistors. Okay. That's a plus. Not for me. I don't get to charge you for any bad pills. Have faith, I might blow something up, but I doubt it. I throw a grommet in here. Let's get some power wires on this thing so we can hook it up and actually see where things are running. I'm going to cut away here real quick. We're going to replace the preamp, do the power wire injection system to this thing, and then we can come and we can do all the tests, like seeing how well the variable works, that kind of stuff. And I'll see if I can find another incandescent bulb to go in here. All right. So, as you can see, quite a few things have changed. First thing we did is we washed it. We got all the nasty flux and dirty hair and everything that was in this, we got it out. And we cleaned it all up. Tweaked the output tune a little bit. Just a little bit, didn't need a lot. Put power wire upgrades on it. Ground, of course. Added some extra capacitors here. Help with the pop a little bit. Then we went and we changed. These are all LED now. Couldn't find another incandescent bulb that was worth a damn. I even changed the internal bulb, so it's now LED. Okay, the other thing that I changed was this cap here, which is our internal sideband delay capacitor. So let's go over here. And now that we're all tweaked out, I'll show you something. Hello, 1, 2. Or like 12.6. So 12 volts. Hello. It's making its rated power now. Hello. At 325 and some change. Hello. Okay. That doesn't impress me much. Let's go up here. Well, it does kind of impress me a little bit because usually they fall short at about 12 volts. Here's our input tune. Hello. 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 It's as flat as I can get you, my man. We did that by adjusting the output tune. Hello, 1, 2. So 200, 300, 325, 230. Let's go over here and let's look at this. That's the radio. That's the amplifier. It's clean, okay? So that's simple. Now, what we're gonna do is we're gonna do silly things. Because these caps have been modified and this capacitor here has been modified, we can do silly things. Before we do the silly thing, let's listen to this. Just the sound of that transistor is completely different. If you want to rewind it and go back and listen to the first test, you'll hear it's, you know, this is more, it's cleaner. Transistor is much cleaner than this one here that came out. Believe it or not, there's different levels of components. There is same part number, you just got to know which lot to go by. It's like saying RG3, let's see, RG316. There's a couple different layers of that, or RG213. There's like 40 different kinds of 213. You've got hard dielectric, you got solid center conductor, you got foam dielectric, you got stranded center conductor, you've got foil wrap, you've got dual metal shield, there's like 15 different layers of 213. And believe it or not, 213 still smokes the shit out of LMR, despite what the frickin' datasheet Nazis want to say. They will go find the worst version of the 213, and then they'll throw it up against the LMR, like, what is it, 300 or 200 or whatever the hell LMR garbage is. And they'll like, see, look, told you, datasheet. Then some of us that know something about coax, we go and we look at the good stuff, the stuff that's got stranded center conductor, a hard neoprene dielectric. It's got a foil shield plus 2 wire shields on the outside of that are actual copper, not aluminum. Unlike the LMR garbage, which is garbage. The 213 smokes the shit out of the LMR. It's just about knowing what little parts we want to tweak to make it just that much better. Okay, now that we have changed out that cap, these caps, and a few other little small parts, like that capacitor there, we changed it out from, instead of being a 16 volt, we went to a 50 volter. As you're going to notice, we're at 15 over here. Uh-oh, We're at 16. Guess what? We're still safe. It's a voltable Texas Star. Okay. What's that do to our drive? At 011. At 011. Brought us up 5-6 watts. But now remember, what we're seeing here is a 25 watt input going into a Texas Star 350. Hello. Hello. 425 from that point of view. We come over here and look at it from where I'm seeing it. Hello. Audio. 475. Look at our amp draw now. Hello. Now we're making power. Hello. 1-1. Okay. We're voltable and we're safe for the most part. Just gonna have to wait until I talk to you tomorrow, my man, since it's 3 o'clock in the morning. I'm gonna call you and find out if you want me to hook up the keying port, which has never been attached to anything ever. I've never seen one of these hooked up to anything. 9 times out of 10, they're not even in the damn amp, but I've never seen that plug hooked up to anything. I will call you tomorrow and see if you want me to, 1, add a fan, or 2, you want me to hook this up so you can use it as a fan plug. So you can get on Amazon yourself, get a fan, get a plug to plug it into, and then plug your fan into the key port. Just saying. In the interim, at 012. The only thing I haven't looked at is needle movement on the front of the amplifier. Hello, audio. Hello, audio. Dial a watt. Hello. All right. Working over there. Hello. Oh boy. That's a bummer. Hello. Hello. Get out of here. The variable just quit. Since 100% of the RF goes through the variable, I know that because our input tune, which was so epically flat, look at this. Hello. That's bad. Okay, so hello, audio. All right. Guess what, man? The part that I replaced that with, they ain't cheap. This is a made in Canada part. Okay. That is expensive, that knob. All right. Well, is what it is. It still has to work. So let's change it out. So this gets better. I'm telling you, this gets better. So, of course, the variable was bad. What was going on is I'd twist the knob. Now we're at full. Okay. I'd turn the knob that much and it would quit putting anything out. That was only part of the problem. Power light's not working for some reason. I'll fix that in a minute. I'll address that in a minute. Okay, so got the dial watt engaged. Audio. So it's nice and smooth now. Audio. Pull dial watt out, and we're right back where we should be. Audio. 400 plus watt box. So, audio. Audio. Almost 500 watts. The other thing that happened is this resistor. This is our little bias resistor. This is the thing that controls the bias for the whole box. This little turd bucket. The reason I pulled it and checked it is because this transistor went completely open. And this one here has a gain of 1 fluctuating to a gain of 0. I pulled and checked this, and it is supposed to be a 1.8 ohm resistor. And it currently reads, I don't know what it reads now, it's cooled off, but when I pulled it out it was a 2.2 ohm, which is not enough to fry the transistors. But this having a short and this one having a beta gain of 1 fluctuating with 0, the transistors were anyhow. It's got 2 used Toshibas in it that both have an HFE gain of over 45. It's like 46 and 47 that are in there now. Non-red dot matched. So this thing is working at 1, 2, 1, 2 as best as it's ever going to work. I mean, short of changing a whole bunch of other little stuff to make it pick up another 25 watts, we could take it so we can make it so it's straight class C and it's no longer biased, and then we could go up in volts to like 17, 18 volts. But for the most part, this is working the best that it can work at the moment. So now let's take some time and fix a god dang power light. Ah! Oh my God. Okay. So son of a bitch. There we go. Okay. I'm telling you, everything has got to be just right. Let's move on to the 667. Okay, so the last thing I have to do before I button this up, and I want to show this to you guys, is the keying plug on the back of the amp, which I've never seen, like I said, wired into anything. How we're going to set that up is so that the center pin's hot, the outer jacket of it's already ground. So if he wants to get on Amazon and buy himself a plug for this, he can just plug into this and run a fan. So when he turns the switch on, it powers up this little piece of wire. It runs to this piece of 43 ferrite. And the idea is that if for any reason that wire ever gets cut, broken, snagged, caught, or anything, 1, it's going to unplug itself. Or 2, you got to be very careful about the size of wire that you use. Like, I wouldn't want to run a piece of like 16 gauge or 14 gauge to this. That'd be bad. Then we could have a fire. So this will act as a fuse per se. I mean, it's not really, but it'll act as a fuse per se. And this wire will give up the ghost before anything else, in theory. So Okay, well, this little guy is ready to go. I'll put the case screws on it here in a minute. Let me get my box of ferrite out of the way. I need that in a minute. Now, let's look at this. After having a conversation with him on the phone today, we're both on the same page on what he wants to have happen. We're going to pull these 4 Toshibas out, these 2 and these 2. I'm going to leave the 2290 in there. That's a beautiful driver for this thing. We're going to put HGs in here. I'm going to do all the McNasty mods to it. Power wire, coax, all that kind of stuff. We're going to pull this key and board out of there. It doesn't even need to be in there no more. We're going to pull the 4 pills out. I'm going to set them aside for him. So these are 8Es. Believe me, once I get them pulled out, we'll document. But you know what? Here, before we go any further, eight E red dots. We're going to set those aside for him. And what he's going to do is he's going to send me 4 more that he has. And we're going to build him an 8 pill out of these transistors and something else. Some other ones he's going to send me. So, preamp, LEDs, LED upgrade, power wire upgrade, coax upgrades, and we're going to put HGs in this. So, I'm going to get on with the McNasty on getting this done, and when we come back, yeah, you guys get it. Okay, so transistors are out. Let's get in here real close so we can document what we got. Okay, everybody see the lot number and the print and everything? Okay. Transparency, transparency. So, $36. All right, that's transistor 1. Put it here. Transistor 2. $34. Put it in its foam holder so it can sit there all protected. Because each one of these is worth about $150 to $200 a piece, it seems like. All right. Transistor number 3. Gain of 29. 29. All right. Still totally viable, 1000% usable, make totally good power. Good stuff. Okay, fingers. Hey, here. You clip on there, you clip on there. There we go. Okay. $29. Okay, my man. I'm going to put them in their little safe cocoon here, and I'm going to set these aside for you. So, and if you want them back, call me. I'll send them back to you. I don't care. It makes no difference to me. Anyhow, we're going to get on with the McNasty on this box. Well, here we are a few hours later. Let's go in here and talk about a couple different things. Okay, so we've got our brand new RG400 coax in there, which is, in my opinion, a little bit overkill. Let's see. Late model. Yeah. Here, perfect example. Okay, had to get myself a demonstration ad here. This is a late model build, okay? The board design on this is really telltale. Let's look right here where this screw is at, right down there. You see how that's a continuous trace? And see, here'd be another good example, right back here in the corner. You see how this is a continuous trace all the way around it? Okay. On the older generations of boards, this is a 667 scabbed board. You notice this trace here is insulated here and here as well. Completely insulated. So are these. And how they would tie these boards to ground is usually through like a 104 disc capacitor, like what's going on here. They've done away with that on these new models, the newer models, which in my opinion is an improvement. But that is the reason that we did not have, see here, here's a new model board that isn't populated. See the difference in the traces? That's the reason I didn't have to do any of the grounding, the extra grounding like I did on the little 350 where I take a ground wire and go from here to here. Which do you think is going to carry more current? That little tiny piss-ass wire or the big metal mass of the heatsink? The heatsink obviously is going to carry way more current. So that's the reason we didn't do that mod. We upgraded the preamp in this thing, of course. And of course did all the power wire upgrades. We changed over, now we've got a matched set of HGs in here. Now remember, in my initial build sheet that the guy gave me, he wanted a flat, perfectly flat, beyond flat input tune. We have achieved that. I'll show that to you here in a minute. It's shocking how low the input tune is. You're gonna love it. Problem is we sacrificed a little bit of peak power, about 45 watts or so. So if anybody can hear the difference on their scale, 45 watts, I'm gonna buy them a bubble gum wrapper. It's impossible. So I would rather go with a perfect input tune than not at all. You're also gonna notice that these caps here have been changed. The reason I had to change these caps is it's just pretty basic. The HG transistor is really close to the Toshiba, but it's not bang on the money, right? It's not dead nuts the same. It's really close. It utilizes capacitance. It requires more capacitance in the circuit than the Toshiba does for it to stay stable, especially when it comes to the flyback circuit, which is a harmonic suppressor, okay? The little tiny capacitors that were in here, when I pulled these out, I measured them and it was like 10 nanofarads, which is like a, what, 100 or something like that, right? The HGs want to have a minimum of 100 nanofarads, as high as 200 nanofarads, for this portion of the circuit to work properly. If I hadn't changed out these caps, when we go to key it up, the box is going to stay operating. It's going to sit there and self-oscillate and create its own power. This is a 104. These are 104s. 100 nanofarads. Like 99.99 nanofarads. If I wouldn't have changed those out, when I first keyed it up, this thing would have just kept going. And the combiner would have gone, and then probably 45 seconds to a minute later, the transistors, because they're oscillating into a dead circuit, not a non-resonant pathway, out to a dummy load because the relay's shut off, they're going to go and fry. So that had to be done. But we put all brand new lights in it. Got a good system worked out for that. It only took about 20 minutes to get that working right. Solid as a rock now. So, I mean, I hate to drop the amp like that, but I'm trying to prove a point. Okay, let's take a quick listen to the preamp. Nice clean static, no overwhelmingly bad shit going on there. Let's go ahead and we'll flip this into the forward position. Let's pull back here a little bit. And now let's look at our 5-watt slug. Let's go over here. This is in the 1x position in PEP. This is in our average or just regular bird reading meter. And by the way, you all know that the bird meter was designed to read sideband and CW, right? Bird had to go and create a peak meter for AM and AM use only to get the accurate reading. You guys all understand that, right? I understand that. I have this here because a lot of people do all their measurements by the average number. And it's not even average. The only time you can have an average reading is when we're measuring something like a consistent current that comes out of the wall. Because we have a modulated signal. We're not running this up with a tone generator, we're running it up with our voice. So therefore we're not going to be able to get a real average reading. But now that meter is dead nuts right when we're on sideband, per se. So they claim at Bird. Just saying. Food for thought. Keep it in there, floating around in the back of your brain. The only one that really matters to me is this one here. This is an afterthought. And especially since we have radios that change how the RF is injected and how much modulation is injected and where. In the AM mode, this is now a variable number. How this meter reads is a variable number. So, okay. Amp is off. And we're going to put a 1/2 watt in this. Ooh, just murdered that 5-watt slug. Let's go over here and let's look at the peak meter. This one here. Hello, audio. Hello, audio. Hello, audio. So we're putting 1/2 watt, hello, audio, and our 20 watts worth of peak. 1/2 watt is getting us 150 watt carrier. So this is all the switches out, by the way. Let's go up here and look at our input tune. It's a 5-watt slug in reverse. Ready? Hello, 1, 2. Hello. 1/10 of a watt. Breathe. Okay. I had to hold that audio. I have a hard time with, let me throw this out there. I could have a tone generator beep running into the mic, or just have a switch. There's a couple of guys that are in YouTube land where they just right on the front of the radio they have a switch, they flip it, and it puts, you know, like 100 or 150 or 200 hertz tone or whatever directly injected into the radio, and it maxes the radio out. I could do that. The problem is that enters a possibility for us to have a lie in what the amp's actually doing for production of power. We can vary that pitch up and down, and it changes how the bird meter reads. It can also give you a little bit false representation of what's going on the watt meter. Because the human voice, let's face it, is not going to work up, you know, for the most part, we kind of run out about 3,200. So if we put, let's say, like a 5,000 or 6,000 hertz tone in it, we're going to get different readings on these meters, and it's going to give you a false indicator. So, hello, 1, 2. That's the reason I use my voice. Okay. Let's show you what happens when we engage the dial a watt button. Look at our dead key. Woo, look at that. Hello, 1, 2. And we're not giving up a drop of peak power. So the variable all the way open. Hello, 1, 2. Dial a watt button out. Hello, 1, 2. Dial a watt button in. Hello, 1, 2. Just saying. Okay, now let's check the amp for linearity. What I mean by linearity is how smooth is our variable potentiometer. Very smooth. Don't have to replace that. Okay, sideband delay. Sideband delay adds yet another layer of attenuation. Hello, 1, 2. Now we're going to go all the way down to low, which is dial a watt and the sideband delay. Hello, 1, 2, 1, 2. Let's go over here. Radio, amplifier, dial a watt out, and AM out. Just because our carrier is so high. We're starting to come into a saturation point in the transistors with this board in this particular setup. So, make this story short there, BBI. Hello, 1, 2. Meter's working perfectly on the front. We're looking here, by the way. Hello, 1, 2. Hello, 1, 2. Hello, 1, 2. Hello, 1, 2. Everything works. It's as stable gets. So, I mean, I could get it to do a little bit more. The max I got this to do is about 750 watts. But the input reflect isn't dead nuts flat. So like I was stating at the beginning of the video about the tin, this is like it was rubbed up against house paint or something. Let's take what's left of the node off the lid. Give me a minute. I have the technology. We're going to fix this. So there we go. Looks like brand new. Cleaned up perfect. Hello, 1, 2, 1, 2. I'm going to call this a win. Just I had to paint a screw. It was short a screw in a cabinet, so I make sure I didn't take my thumb with the semi-wet paint on it and touch the face of the button. Okay, that's it. This one and this one are ready to go home. That's it. Gentlemen, I want to say thanks to the Patreons. Without the guys on Patreon, I don't know where I'd be. I'd have to work really hard. So I give thanks to them guys on Patreon. I really do. Let's give a shout out to Matchlet, MacMan, Siglant, XS, Penalabs, Bird, Coaxial Dynamics. All of those people help us all be here. If it wasn't for all of you, shit, I'd be just standing in a shop talking to myself, pretending like I had something important to say. But then again, I don't really have anything important to say. Gentlemen, thanks every single one of you guys. Appreciate you for tuning in. If you could do me a favor, give me a thumbs up. I greatly appreciate it. And just so you know about the time that you're watching this, I most likely will be on my one vacation I allow myself to have a year, which is for my wedding anniversary. It also happens to coincide with my better half's birthday. And it also happens to coincide with a break that's taking place at the same time. So I'm going to go to a break. I'm going to take my wife on a vacation. And we're checking out of this place for about 10 days. So if I don't get in contact with you between the 11th and the 21st, y'all know why. I appreciate you, gentlemen. On to the next project. I'll see you. Click, click.